In this video, I'm going to show you how to find important characteristics of dot plots, histograms, and box plots. We've been using dot plots in our previous videos, so I copied two of the dot plots from the previous video. The one on the left is the height of male basketball players in inches, and the one on the right is the height of male middle school basketball players in inches. Below each dot plot is a histogram and a box plot. The histograms and the box plots were created with the same exact data as the dot plot above it. So I'm basically showing you three different ways to display the same data. And we're going to talk about some of the benefits and drawbacks of each type of representation and how we can find different characteristics of the data depending on what you're looking at. So just to recap with the dot plot, let's start with the one on the top left, the height of male basketball players in inches. In the last video, we talked about how you can find the shape by drawing a curve over the top of all of the dots. And this dot plot gives us a very symmetrical bell-shaped curve, and it only has one peak, so we know it's unimodal. And whenever something is symmetric and unimodal, we call it a normal distribution. We can find the same shape by looking at a histogram. If I look at the histogram below it, I can also draw a curve over top of the heights of each bar, and I get that same bell curve. So I know that just by looking at the histogram, I can also tell that this is a normal distribution. You might be wondering how we're going to do this with the box plot because we can't draw a curve like this. When you look at the box plot below, you can see that it looks very symmetric. The box is about the same size on both sides. The branches are about the same length. So we can tell, because this is so symmetric, that this is a normal distribution. So no matter what type of display you're looking at, you can determine that normal distribution shape. We can do the same thing with the distribution we have on the right. So what we did in the last video was we drew the shape over the dots, and because of the two dots on the right, it creates this tail on the right side, and because of the tail, we call it a skewed right distribution. The tail is on the right, so it's skewed right. I can draw that same shape when I'm looking at a histogram. I can draw over the heights of my bars, and I still get that similar shape where I can tell that I have a tail on the right side, so it must be skewed right. With the box plot, again, we can't draw the curve, but we can look at this box plot and see that on the right side of the box is stretched out and the right branch is much longer, whereas on the left side, the box is much smaller and closer together and condensed. So that stretched out side on the right shows us that we have a tail on the right side. So once again, we can tell that this is skewed right. So once again, whether you have a normal distribution or a skewed distribution, you can tell by looking at either the dot plot, histogram, or the box plot what shape the distribution is. Now let's find some important characteristics using the histogram and the box plot. So for our data on the left side that's normally distributed, in the last video we talked about how the mean, median, and mode are all good measures of center for this normal distribution. Whenever you have a normal distribution, mean, median, and mode will all be the same. And in this case, they're all equal to 71 inches. Now, you can also find the median or the mode by looking at the histogram. Let's first talk about how we read a histogram. In a histogram, we have a bar in each range of values, and these range of values we call our bins. So, for example, the first bar on the left is the range of values 64 to 65 inches. That's our range of values, or our bin, and we're going to put the number of people that belong in that bin to tell us the height of the bar. So as we can see, this bar is between 0 and 2, so we can tell it's at 1, which means there's one person that falls into this bin of 64 to 65 inches. Now, you might be thinking, why aren't we including the 66? In a histogram, we never include the value that the right side of the bar is touching. So you always only include the value on the left and then the values in the middle. You never include that value on the right side of the bar. So the next bin we have is 66 to 67 inches. Remember, we don't include 68 because that's the side the right side is touching. So in this bar, it's going between 2 and 4 is the height of 3. So that means there's 3 people in the range of 66 to 67. We can check this by looking up at our dot plot and see how this connects. From 66 to 67, you can see I have 3 dots here. That's why the bar goes up to 3. Okay. The next bin is 68 to 69, and that bar goes up to 5. So there's 5 people in that bin. The next one is 70 to 71, which goes up to 7. So there's 7 people there. The next bar is 72 to 73 inches, and that bar goes up to 6. The next one is 74 to 75 inches. That one goes up to 4. And lastly, we have 76 to 77 inches, and that bar goes up to 2 people. So now that we understand what a histogram is telling us, the reason we can't find the mean using the histogram is because when we find mean, we need to add up all the individual data values. And based on a histogram, we can't tell whether, for example, in the bar from 68 to 69, we can't tell how many of the 5 people are 68 inches and how many are 69 inches. We only know that there are 5 people in that range. So because this is kind of more of a general summary of the data, we can't calculate the mean the way we would in the dot plot. So instead, we're just going to talk about median and mode. So for the median, when we were in our dot plot, we would cross off one dot on the left, one on the right, and work our way in. Now, we don't have dots here, but we can do something kind of similar. So what we want to think about is, first of all, how many people are in this data, and that is 28 total. There's 28 total people, and since we want to find the median, which is in the middle, we need to think about how many people would it take to get to the middle of 28. Since 28 is an even number, there's not an exact number in the middle, but 14 is half of 28. So we can look between the 14th and the 15th person to find the middle value. So what I'm going to do is start on the left. So again, I take the total number of people, divide it in half, and look for that person by looking through my histogram. So I'm going to start on the left side of the histogram and count the people until I get to 14 and 15. So I've got 1 person on this bar plus 3 on the next bar gets me to 4. I'm still not anywhere close to 14 or 15, so I don't know what my median is yet. Now I'm going to keep adding on. My next bar is 5, so 4 plus 5 gives me 9 people. I still haven't gotten to a range with 14 in it. Next I have 7, so 9 plus 7 gives me 16 people. So that means my 14th and 15th person must be in this middle bar. So that means the median must be between 70 and 71 inches. So unfortunately, this is a drawback of a histogram, as we can't get an exact value for our median, whereas in our dot plot, we knew for sure that it was 71 inches. Now our mode, we know, is the peak, or where we see the most number of people, which is that middle bar with 70 to 71 inches. Once again, we don't get quite as certain of a value, but you still have to be able to have an idea of what the median and mode would be by looking at a histogram. Let's do the same thing with the histogram on the right side. Let's label each bar with the values in the bin and how many people are in them. So the first bin is 64 to 65 inches, and there's 2 people there. The next one is 66 to 67 inches, and there's 5 people there. The next one is 68 to 69 inches, and there's 1 person there. 70 to 71 inches has 1 person, and 74 to 75 inches has 1 person. So to find the median, this time we have 10 total people, which is still an even number. So I'm going to be looking for the person that's number 5 and number 6 and look in between those people. So I'm going to start counting from the left side. There's 2 people in the first bar. So the 5th and 6th person are not in that first bar. Plus 5 people in the next bar gets me to 7. So that means my 5th and 6th person must be in this bar. So the median must be between 66 and 67 inches, which, as you can see, it does make sense because up here we had a median of 66.5 inches in the dot plot. So that matches with what we're figuring out in the histogram. And the mode is where we see the most number of people, or the highest bar, which is the bar with 5 people at 66 to 67 inches as well. All right, now we can find out some more information from our box plots. In the box plot, we're going to be identifying the minimum, the maximum, the median, and then quartile 1 and quartile 3. And I'll talk more about what those are as we get into it. So the minimum and the maximum are pretty easy because the minimum is all the way on the left side, that line all the way on the left side, and it looks to be between 64 and 66. So the minimum is 65 inches. The maximum is the farthest point all the way on the right, which is between 76 and 78. So that's 77 inches. And the median, since that's the middle, you might have guessed, is this line in the middle of the box, which is at 71 inches. Now, a box plot has 4 different parts. So the box plot can easily show us where each quarter of the data is. So for example, we have 1/4 or 1/4 of the data here, We have another fourth of the data in this section, the third one in this section, and then the last quarter of the data falls in this section. So just like how the median splits our data in half, the different quartiles split it into quarters. So quartile 1 is where we see the first quarter of the data. So quarter 1 is this line between the minimum and the median. And quarter 1 looks to be a little bit after 68, so 68.5 inches. Next, we have quartile 3, which is where we see after 3/4 of the data. So that's the line between median and maximum. And that line is a little before 74, so 73.5 inches. So that's how you can find more information about the data that we couldn't have found in the histogram or the dot plot. It's really easy to see the quartiles in the box plot, whereas it's not as easy to see in the histogram and the dot plot. So that's one benefit of a box plot. All right, our last box plot, we have our minimum all the way on the left at 65 inches, our maximum all the way on the right at 75 inches. Our median is that line in the middle of the box, which is a little past 66, so 66.5 inches, which again, that makes sense because we had our median as 66.5 inches in the box plot, in the dot plot. And then quartile 1 is the first line between the minimum and the median, which is at 66 inches. And quartile 3 is the line between the median and the maximum, which is at 68 inches. So all of these distributions give us different information about the data, and there are benefits and drawbacks to all of them, but you should feel comfortable at least being able to identify the shape from all of them and the median and getting a general idea of the data by having any of these distributions in front of you.